Welcome to our conversation today in the Enable Speaker Series. Our title today is Enhancing Decision-Making Through Interactive Data Visualization. My name is Paul Pangaro. I'm Professor of Practice in the Human-Computer Interaction Institute, also known as the HCII, part of the School of Computer Science here at Carnegie Mellon. Here at CMU, the School of Computer Science and the Tepper School have created Enable, which is your hosting organization today, which we talk about as a retail and services collaborative. So our mission is more humane, efficient, and positive retail and service experiences. And we feel that we are creating a unique forum to help the retail and service industries meet the needs of their customers through advances in tech, yes, of course, but equally advances in interaction design, service design, and ultimately organizational design, because all of these are necessary to successfully adopt any new technology. So with this unique combination of these areas of design and technology in a single initiative, we're bringing to you another event today. There's more on our site. Get in touch if there are specific areas that you're interested in. We're at cmu.edu/enable, E-N-A-I-B-L-E. And we want to thank our wonderful sponsors, Zendesk and Progressive, who help us bring this to you today. A couple of brief logistics before we get to it. This event is on the record and is being recorded. If you'd like to pose a question, you'll have a button at the bottom of your Zoom screen that says Q&A. Please post your question there. We'll put them in the queue and do as many as we possibly can. So after a couple more intros, our speaker will talk for 25 or 30 minutes. We'll open to questions. We'll go until 2 for sure. Sometimes we go longer, no commitment. But when the conversation's good, we don't like to cut it off right at 2 o'clock. So here we go. Today, we're exploring how data visualizations, and not just any kind, but rather interactive data visualizations, and how they facilitate the human involvement in machine-assisted decision-making. The conviction is that the story that the data tells has to be clear. And when that story is clear, better decisions are made, and that improves ultimately the customer experience. I don't think we need to speak to this audience about the size and complexity of the data coming at us all, especially in retail and service, and the importance of that data, and the growing importance of AI as a competitive advantage. It's becoming table stakes, if it's not already, to look at the data, to automate the processes, and to enhance decision-making, because of course the humans are in the loop with defining goals and checking errors and ultimately deriving value for the business, for the stakeholders from the results. So today we'll be discussing how this can work, and we'll look at some tools to make it straightforward and to analyze and present data that can apply to everyone in business to become better data analysts. Well, that's a wonderful old-fashioned term. And data communicators, an important modern term. So let me introduce our guest today. Our guest is Dominik Moritz. He's a colleague of mine in the HCII, the Human-Computer Interaction Institute. Dominik is Senior Project Scientist and co-leads, this is quite important and interesting, the Data Interaction Group, which is dig.cmu.edu. And his group's research develops interactive systems that empower a wide range of people, essentially anyone who has interactive data needs, to effectively analyze and communicate the data. Dominik may be a little modest about it, but he's very well known in this field and has been one of the seminal people in systems that you will hear the name of now, perhaps for the first time, but very important systems. One is called Vega Light, another Falcon, Draco, Voyager, and others. And he's won awards at academic venues on this. Dominik, welcome. Thanks very much for joining Enable.
Thanks for having me.
It's great to have you. I feel like I'm talking to a great expert. You know, I'm springing this on you for the first time. The first computers I ever used did computer graphics, and I fell in love, and I've always been interested in what you do, as well as moving into the media and artistic side of the same thing, but it's all about storytelling. I agree with you about all of that. My first question is, how do you measure the size of your community, and how large are the user sets that you have? How big is your user base?
Yeah, what you said about visualization, I think is pretty interesting in that it combines art like computer graphics, drawing, rendering, with statistics, storytelling, and computers and algorithms.
Fantastic.
And because it's hard to quantify exactly the size of the community that's using the tools that we're building, because they are open source, they're available to anyone who wants to download them. But we do have some numbers of downloads. So for instance, Vega Lite, one of the tools you've mentioned, which is a language for describing visualizations, is downloaded about 2 million times a month from a CDN, which is a content delivery network, a system for publishing software. So we have quite a number of users there, but it's also used at universities for teaching, and larger companies are also using it internally and externally.
2 million downloads per month. That's.
Yeah, I wish I knew exactly who all these people are.
That's a lot, because then you could market to them, I suppose. But of course, your community, I know, has a lot of vibrancy in how you stay in touch with them. Well, let me let you get into it, and please show some slides, and we'll talk along the way, and there'll be time for Q&A later from everyone. And also, Dominik, I know you're willing to have interruptions, is that right? So if we see something interesting in the Q&A, we might break in.
Yes, you're welcome to interrupt me. So I'm going to talk about enhancing decision-making through interactive data visualizations. And yeah, feel free to interrupt me at any point if you have, and I'll also leave some space for asking questions. Yeah, so this talk is about interactive data visualizations. And to understand what I mean by that, let's jump straight into an example. This is a basic visualization type, a scatter plot. And it's a homage to Hans Rosling, who was a famous data visualizer. And what this data shows here is development data for different countries. So we have on the y-axis life expectancy, and on the x-axis fertility, measured in children per couple. And so this static visualization already gives us an overview of where different countries are here in the year 1955. We can get additional information through interaction. So for instance, we can hover over a point to see its trajectory that it takes through time. So here, South Korea, Indonesia. And we can also move through time to see how different countries are developing in tandem. And so you can see some of the outliers here, such as Rwanda, which had a terrible genocide in the 90s, but generally countries are moving towards this upper left of lower fertility and higher life expectancy. And so through the visual encoding, so making data in a chart, and interactions, we get more insights into some data. And what I want to show you today is that I create visualization languages to make visualizations like this one. And at the end, we're going to have about 6 takeaways about data visualization. The big takeaway that I think is that well-designed visualizations are an effective way to analyze and communicate data. The first takeaway within these 6 is that AI or statistics need to be augmented with visualization to facilitate human involvement. And this insight goes back to the 1960s. Tukey, an influential statistician who, among other things, invented box plots and also coined the term bit, wrote that exposure, the effective laying open of the data to display the unanticipated, is to us a major portion of data analysis. Formal statistics has given us almost no guidance to exposure. Indeed, it is not clear how the informality and flexibility appropriate to the exploratory character of exposure can be fitted into any of the structures or formal statistics so far proposed. And statistics here in the 1960s could be a stand-in for AI or machine learning today. They continue. Nothing, not the careful logic of mathematics, not statistical models and theories, not the awesome arithmetic power of modern computers. Nothing can substitute here for the flexibility of the informed human mind. Accordingly, both approaches and techniques need to be structured so far as to facilitate human involvement in intervention. And as critical as it is for statistics and data analysis, it is also for AI and machine learning. And to illustrate this point, I want to show you 4 data sets For each of these data sets, we have a column of X values and of Y values. And well, just looking at the data, you might see some patterns, like dataset 4 having mostly 8s on X and then 1 19. But otherwise, it's fairly difficult to see what is happening in this data. So if we were to use statistics, we could start to look at the averages of X and Y, or the standard deviations. And it turns out they're all the same. Every set, 1, 2, 3, and 4, have the same basic statistics. They have the same average on X, same average on Y, same standard deviation on X and Y. They also have the same correlation between X and Y. So basic statistics doesn't give us any hint about what's in this data. Well, if I plot this data, you'll immediately see what each of these data sets are. So here are the plots. And you can see set 1 goes generally up, has a couple outliers. Set 3 has this very clear line, and then there's one outlier. Set 2 doesn't look like a linear correlation at all. It's more like a parabola. And then set 4 has this one outlier, and that we could see, but now it becomes much more obvious. So here, through visualization, the relationship becomes much more clear. So the takeaway is that machine learning, AI, and statistics are people problems. For them to be effective, we need to design for human involvement. So how do we make charts? Well, there's a number of visualization tools we could use. Some are more designed for making custom visualizations, such as D3. But it often takes a long time to make a particular chart. The alternative might be tools like Excel, which have a set of pre-canned visualizations. But these are often not flexible enough to support the range of graphics or charts needed for effective analysis. So how do we make visualizations in the midst of an analysis? Well, you could use tools like Vega Lite that we mentioned earlier to actually make the visualization that I showed you at the beginning of this talk. So the visualization I made in an online editor that my colleagues and I built. And this is the editor for this language, Vega Lite, which is a high-level declarative grammar for making visualizations. So what I mean by that is that we are describing graphics as a mapping from data to visual properties of a mark. And in our specification format, each component in the specification corresponds to one component in the chart. And so there's a direct mapping here. And the system then synthesizes appropriate visualizations with the right components.
Dominik, I want to interrupt. It sounds like a fancy thing, grammar, and yet what you're showing is essentially code. So if someone is a capable coder, they can do what you're talking about. There's nothing special beyond the idea that it's a subset of all possible coding in order to create visualizations.
Yeah, the special thing about the idea of a grammar here is that rather than picking from a set of visualizations, we're composing a chart by specifying the mark and then how we map data to properties of that mark. So here in this case, the mark is a bar, and we're defining its position, its color, its size, and so on. And through that, we can express a big variety of graphics. That's the idea of a grammar. So it's both flexible, and I only have to learn a small number of concepts. And it also enables us to build, to automatically reason about visualizations. Something I'm not going to go into too much detail today, but it's something that the system enables.
Thank you.
Thanks for the question. So Vega Lite is designed for analysis, and therefore it can be concise and flexible. And we mentioned earlier that it has about 2 million downloads from a CDN and is used by various companies, including Apple, Microsoft, Google, Netflix, and so on. And it's available as open source on vega.github.io/vegalite. I can share the slides at the end so you don't have to necessarily take notes of all the links. So the takeaway here is that grammar-based visualization tools, such as Vega Lite, support flexible interactive visualization and exploration. Because of this grammar approach, Vega Lite represents a combinatorial space of possible designs, which are defined by atomic updates to a Vega Lite specification. But just because we can render a chart doesn't necessarily mean it's useful or not misleading. And to illustrate that point, let's look at making a visualization. For this data set here, which shows us barley yields for different sites. So we have a table that has the year, the site where the barley comes from, and the average yield. And just by looking at the table, it might be hard to see again what's happening in this data. So we could start plotting it. And for each year, show the mean yield for each site and color the site or color the points by the site. And now we can see that there might be a trend. From 1931 to 1932 is generally a decreasing yield. But there's something special here. There's something wrong or something unique about this data. And it only becomes obvious when we change the visual representation slightly and switch from a point to a line encoding. So here we just changed the mark type. And now our visual system can kick in and immediately recognize that there's this one outlier, this Morris site, where the yield actually increased while all other ones decreased. So the visual encoding here changed whether our visual system can kick in and help us recognize this outlier. So it is important to help designers and analysts create effective visual designs that highlight unique things like this. And to facilitate this and make it easier for people, we've built a tool called Draco, which is a formal model of visualization design and learned constraints, and it can be used to automatically create good visualizations. So for instance, you can input a prompt. It would be in a more formal way, but you can imagine something like this to visualize the temperature in the weather data set, and the system would then generate an appropriate visualization that leverages insights from design and psychology and human cognition to make a visualization. So the takeaway here is that when we design for perception, otherwise hidden patterns emerge. And tools can support analysts by helping them make good encoding choices. So that's a takeaway about making good charts. So now we've talked a lot about making charts, how you can make them, and how you can design them well. But really where we want to go is from making just the visualizations and designing them to exploring data and making decisions. So how might we support effective exploration? Well, given the data set, we might have some assumptions. And as we interact more with the data, we might get new assumptions. So how do we make this process of creating hypotheses and testing them more effective overall? Well, tools can also play a role. And to illustrate that, I want to look at a movies data set. This has data about the title of the movie, its ratings, and the release date. And just looking at the release date, it is important to recognize that there might be errors in the data or problems that otherwise affect our analysis. So for instance, if we visualize the release data, we can see here the numbers of movies over time between the years 1930 to 2040 something, let's say 45 roughly. Well, we can see a couple of things. First, we can see the stark drop-off in around 2010, which corresponds to the collection date of this data set. And then we can also see that there are movies from the future. Well, that's odd. They're even from the future, like far into the future. Probably these movies haven't even been thought of yet. Well, what probably happened is that there were either data entry issues or that the data was parsed incorrectly by some automatic data ingestion. And so the lesson here is that there are a lot of common data analysis pitfalls, and we have to make sure that we look at our data and test our assumptions before we go into further analysis. And visualization can really help us there. And it can help us to recognize and overcome common analysis pitfalls like overlooking data quality issues, or fixating on specific relationships, or other cognitive biases. we've built a tool called Voyager to address these common issues and kind of encode best practices in it. And the way it works is that you start by loading a dataset, here the movies dataset, and it immediately shows you all the distributions, including the release date. And so you can see that there might be movies from the future. You can also start looking then, once you've done that, at more relationships, such as the relationship between IMDb rating and Rotten Tomatoes rating, and what might be a predictor or the underlying cause for having particular ratings. So what the system does is that it automatically recommends visualizations that might be showing you the next step in your analysis. So this is Voyager, and the takeaway here is that UI tools can encourage analysts to follow best practices. Okay, let's look at another example, one last example, where we start with looking at univariate summaries in order to make sure that we don't overlook any data issues. And the particular data set I want to look at is about flights. It's a data set from the FAA about flights and flight delays. And this data set is of all commercial flights in the United States since 1987. At the time when I recorded this, there were about almost 180 million flights. And what I've shown here is for on the count on the right, and then I discretized, I binned each of the dimensions I want to show, and then counted how many flights fall into each of the bins to get a sense of the shape of the distribution of each of the variables. What this data shows us is how much the flights are delayed. So here we have the arrival delay in minutes, the departure time, what hour of the day the flight departed, and how far the flight went. So whether it was a short distance or long distance flight. And so by visualizing the distributions, we already get a sense of, well, what is in our data. And you can see that most flights depart, for instance, after 6 a.m. and then there's a drop off towards midnight. But if we really want to interrogate the data further and explore multidimensional patterns, we need interactions. And what we might ask, for instance, is what makes flights arrive before their scheduled time? Just by looking at these histograms, we can't really tell that. But we can engage in something called cross-filtering. What we do there is select some flights that are arriving, look at the flights that are arriving early and see how the distributions change. What we can see is that the flights that are arriving early seem to be the ones that are going further, which kind of makes sense. Those are flights that can make up for any potential delay that might have occurred. We can also look at the opposite and see what makes flights very delayed. And now we see more movement in this departure time diagram, showing us that it's the later flights in the day that have very long delays. Which again, probably makes sense because it's the flights where any delay that might have occurred before also then affects later flights. So now we used interaction to look at multiple dimensions at once and look at their relationships, something we couldn't have done in just a static visualization. We can go even beyond these looking at 2 dimensions at once and interact and, for instance, see whether this effect of delays generalizes to long distance flights. So here I'm selecting the longly delayed flights and the long distance flights. And you can see that for long distance flights, this diagram is very similar for the departure time is very similar to what it was before, telling us that long flights, even if they're late in the day, don't necessarily have this delay. And so the takeaway is that interactivity enables us to find patterns that exist across multiple dimensions. So this is the power of visualization and interactivity together. And there's one other thing that's happening here. Looking back at this state here where I selected the very delayed and long distance flights, you can see on the right that it's only 13,855 flights that are in this selection that are falling, that are both very delayed and long distance. And that's only 0.008% of the overall data set. And so it was really important to do this analysis on the full data set of 180 million flights, and not just using a small sample where, yeah, this effect we wouldn't have been able to make a robust, drawing a robust conclusions from this data. So how do we build tools that enable us to interact with billion record data sets in real time so that we can do what I just showed you? Concretely, the goal here is to interact with large data at the speed of human thought. And this real-time aspect is actually really important. There's been research that showed that delays reduce engagement and lead to overall fewer observations. And delays might bias the analyst towards convenient data, along with all the implied selection biases. So to address the scale and interactivity at scale, we've built a tool called Falcon, which enables zero latency cross-filtering for massive datasets. In fact, the interactions I've shown you before with the flight dataset were a screen recording from this tool, which was running in my browser. So this zero latency interaction is available in the Falcon system, and it leverages smart prefetching and precomputation designed around human perception to enable these fast interactions. And similar to all the other tools I've shown, it is available as open source at github.com/vega/falcon. And as the takeaway for today from Falcon is that interactivity should be real-time regardless of the scale of the data, because only then we can really unlock all the insights and all the hidden patterns that might exist, even in just small subsets of the data. So these were the 6 takeaways. Here are they all on one slide. Starting with machine learning, AI, and statistics are people problems. And for them to be effective, we need to design for human involvement. I've showed you grammar-based visualization tools that are specifically designed for analysis. And I showed you that they're more flexible for making interactive visualizations, but also much faster for exploration. I've showed you that when we design for perception, then otherwise hidden patterns can emerge. And tools can help us to do that. UI tools can also encourage following best practices in analysis. I've showed you that interactivity enables us to find patterns that exist across multiple dimensions. In the first example, I've also shown you that interaction enables us to look deeper into data, like seeing the traces of the countries as they move towards higher life expectancy and lower fertility. Or when we hovered over a point, we could see which country it was, which otherwise was hidden. And I've also lastly then showed you that interactivity should be real-time regardless of the scale of the data in order to really unlock all the insights into the data. So these are the 6 takeaways today. This is research done with a lot of my colleagues, both at CMU, the University of Washington, at MIT, and others. And at the university, at Carnegie Mellon University, in our lab, we're building these tools, and we're following our mission to empower everyone to effectively analyze and communicate data. And we do this by designing interactive systems that richly integrate the strengths of both people and machines. You can learn more about our research at dig.cmu.edu. And also there's ways to get in contact with us if you want to use any of the tools or want to support the kind of research that we're doing, or are interested in maybe seeing how some of the ideas could be adopted to your context. So yeah, please feel free to get in touch. All our contacts or information is on the website.
Wonderful, Dominik. Thank you so much. Clearly, you shaped your presentation as a storyteller as well. So the storytelling is in your structure as well. I appreciate it very much. It's fantastic to see the role of visual design in the design of the interactivity, and always trying to design for the intention of the user to learn something from the data. What story does the data tell, as you put it? When we read a chart from a piece of paper, the story is baked in, right? And maybe it's a good starting point, but the emphasis that you're making on the interactivity of it, it's almost, in my terms, I would call it a conversation with the data. And that's the reason why you need the real-time quality, right? If you asked a question and you had to wait a long time, it wouldn't have a fluidity to it. There are some questions coming in, and I'll intersperse them with some other comments I'd like to make. One question is, can you please elaborate on what you call design for perception?
Yep.
A little bit here, please.
Yeah, so the example I gave was where we switched from a point encoding from a point mark to a line mark. I can pull up that example real quick again to illustrate.
Beautiful.
Yeah, so in this data set, right, just looking at the table, it's really hard to see what is happening between the different sites, between the 2 years, 1931 and 1932. And by visualizing it using just a point, we can maybe see that there's a general overall trend. But the outlier, the Morris site, is you actually have to look at the data and look at every value one by one before you see that Morris behaves differently from all the other sites. If instead we're creating a visualization where we're using a line mark as the encoding, as the mark, now I don't have to read every single value. It immediately jumps out that there's something different about this one value. And so what I mean by designing for perception is leveraging what we know about in the research community about, in the design community about designing such that our visual system can immediately recognize patterns. And this is just one example, choosing a mark that shows the trend well. There's a lot of other important things, like using the most effective visual channels first. The most effective channels are actually the positional channels, so X and Y. And you should use them before using other channels such as size or color. And I've already followed most of those principles here in designing the visualizations. And so that's what I mean by designing for perception. The idea with the Draco tool is that it encodes what we know from perception, cognitive psychology, and so on about how to design such that you can recognize patterns quicker. And also that what the visualization shows maps to what the data shows. And that's very important to do. So those two things.
We're getting some great questions here. Please continue asking them. So we talked about code, and we talked about the flexibility that the code gives you, and that you're establishing a grammar that people can follow. How hard is it to learn these tools? And the corollary question is, can you start from pre-existing library functions and then move into the hand coding from there?
Yeah. Learning these tools and designing tools for learnability has always been very important for us. And one way we've addressed this is very inspired by previous approaches, or by previous tools such as D3, is by making lots of examples and using them as starting points for making your own visualizations. So this is particularly true about Vega Lite, which is used by teachers to teach at universities in visualization classes to teach visualization design, but also companies and analysts and data enthusiasts around the world. The tools are designed such that even a short specification gives you a valid chart so that you can start to see something and then modify it until you have achieved the final visualization that you want. So they're already designed for making it easy to create visualizations. With all these coding languages, grammars, and so on, there's always an issue about discoverability. Like knowing that a certain feature exists is important before you can use it. And one way to address it is through having a UI that has all the options visible. And so that's why we built, for instance, the Voyager system, where you don't have to know all the details of how Vega Lite works. So Voyager uses Vega Lite under the hood, but it exposes automatically the different aggregations that you can call, the different mark types that you can use. So you just pick them from a dropdown. To make it easier to write code, we've built, for instance, this online editor where I created the visualization that I showed. Well, most of them I showed today, but particularly the first one of the development data. And it has, for instance, built-in autocomplete and some error reporting so that you make it easier to make visualizations.
A quick side question, which has also been on my mind, and then we'll come back to the deeper ones, as well as the role of AI and so on. Are there stories behind the names of the systems that you and your collaborators have built? We'd love to hear about those, Draco and so on.
Yes, they are a lot of, there's a little bit of a history of naming visualization tools in research after astronomy and star-related things. This, I think, started with the Polaris system, which was a research paper out of Stanford that then later became Tableau, a $1 billion visualization company that was bought by Salesforce. So the Polaris paper was the beginning of Tableau. And Polaris is the pole star. So it's a star. And then Vega is is close to it, the star that's close to it, which is actually part of so there's a couple other stars around it. Voyager is the Voyager probe that goes to explore the stars. Falcon is the Millennium Falcon, which also goes to fly to the stars, and it's very fast, so enables fast interaction. Draco is a star constellation. Vega Lite is just the lighter version of Vega. Honestly, not the greatest name, but it's kind of stuck. So that ship has sailed in a way. What other tools did I have? I have a couple other ones that I didn't talk about today. They're all somewhat star related.
In the same genre, as we say, of naming conventions. What a great history. Yep. That's fun. Yeah. So let's come back. Yes. Go ahead, Dominik.
Yeah, the name Vega I think is particularly clever. My advisor created this because it's both a star, but it's also, the short version is VG, which could stand for visualization grammar. Vega is a visualization grammar.
I didn't get that. I'm glad you pointed that out. That's
sometimes multiple levels and all these things.
Fantastic. So let's come back to some details. One of the questions here is, and you may have it in front of you also, Dominik, but I'll read it for the audience. Some outliers in the data might have little to no implication, while others can have, quote, hidden implications, unknown, yet to emerge value.
Yeah.
This exploration and interactivity identify the implications of an outlier. Very tall question.
Yeah, it's a great question. So outliers, there's different kinds of outliers. There's there's data entry issues where just the data is wrong, like movies from the future. Actually, in that case, it was just a parsing error, that probably movies that should have been in 1920 or 1930 were like moved to 2030. So in that case, you probably want to maybe entirely remove them. But there's also outliers that are actually in the data, where it's like, let's say we have income, and then you have Bill Gates all of a sudden. That changes the averages, but it's actually a data point. It's not incorrect data. And so distinguish between these two cases is really hard. Interactive visualization, I think, is a really good tool to explore different scenarios if you look at the data with and without the outlier. One way to do that is through, for instance, this cross-filtering that I showed on the flight data. If you can see, what do my distributions, what do my conclusions, right? If I run an algorithm, what do those look like with and without the outliers included? I could, for instance, brush over, let's say if I have the movie data over the years, and see how does this affect the other distributions if I include the movies from the future or not. It might actually not affect it that much because there actually weren't that many from the future. So maybe our conclusions wouldn't change that much. But we can test that and try out different scenarios, try out different filter conditions, for instance.
We have a couple of other tech low-level questions, but let's zoom out for a minute and talk about AI and the complementarity between AI and human intelligence. You haven't yet spoken about AI. Do you have any examples where AI comes in and this synergy, or what Engelbart called well, actually Licklider called man-machine symbiosis, but Engelbart was also big on when he talked about augmented intelligence.
Yeah, you're absolutely right. I didn't show any AI or machine learning for the analysis itself. There's actually some in a lot of the tools that I've shown. So for instance, the Draco tool, which does recommendation, it uses a knowledge base, a declarative knowledge base of visualization design, and then applies a constraint solver to find out what are valid visualizations that are also also have the best visual encoding according to a number of rules. And so that's using an AI system, pretty classical AI, so not the statistical machine learning tools, but more like classical AI. Similarly, the Voyager tool underlying has something similar to Draco for recommending visualizations. So that's where AI and machine learning comes in some of the tools that I've shown.
Where do you
but otherwise, yeah, you're right. There's more applications that I haven't talked about.
Can we speculate a minute? Where do you see that going? Where do you think AI will be in 3 to 5 years in the world of data viz? What do you think it'll be helping with?
I think leveraging, it's in two ways. One is leveraging AI and machine learning for building tools that support analysts, for instance, by directing their attention towards particular outliers or recommending good visual encodings. And then the other way around, using visualization to actually understand machine learning. In the machine learning process, there's a lot of steps where visualization can help us. For instance, after the data collection, we have to do an initial analysis to even know what are the distributions in our data, what are potential problems with the data that might affect our downstream analysis. Once we're building a model, checking the outputs. When we deploy the model, we have to keep monitoring it and make sure that our distributions that we trained on are still also the distributions that we have in the real world. Because if those two are different, our model is essentially invalid at that point. And so making sure that we monitor what is happening, visualization can help us there, because visualization is, in a way, is a way to get a lot of data from a computer into a human. Right? I can only look at so many numbers in a table, but if we convert numbers into color, position, sizes, we can essentially use the whole screen that we have with millions of pixels. And so much larger data sets can be communicated to people.
Dominik, I'm curious.
Mm-hmm.
When we talk about storytelling, of course, there's fiction and nonfiction. Mm-hmm. And how much do you think about the data as being reality and the visualization as being reality, or some mapping or framing? What's the transformation between the raw data, the numbers in the charts that you show, and the thousands of ways that you could actually express this visually?
Yeah. So just assuming that the data is what we have and making that visual, there's different ways to show it. Mm-hmm. And there's different ways to process it. And that can show different angles to it, that can highlight different aspects. And all the choices that we're making are influencing what the stories we're going to tell in the end. And it can be, we have to be very careful there. So there's no truth in any of those. I would say this starts even earlier. Data is not facts. Data is not truth. Data is a recording of something. It's messy. It's often only a sample because we don't have all the data. We only have sensors that are capturing some of the data. We might have some data lost. We only have the data if you're, like, let's say in retail, we only have the data from our stores, but not from others. And So it's always a subset. We might have missed something. We don't know about the future, so there's always something missing from the future. Can't record everything. Thank God we can't. And so data is always just a recording. It's just a snapshot of the reality. And so visualizations can also always only show that part of the reality.
I'm glad to hear you say that. I didn't know what your answer would be, but I think it's much more responsible to realize that what you pay attention to is what you're paying attention to. So it's also a matter of the data sets that you think are valuable and the data sets that you don't think are valuable. Obviously, bias is a tremendous issue here, and we talk about that now in AI all the time.
Yeah.
But I think it's important to keep that in mind responsibly as you process the data that you have for whatever reasons, your selection or what's available, good samples, bad samples, all the way up to telling the story to yourself and to others on the team, other stakeholders, other people that are in the conversation with you. Because if you present it as truth, I think that's not responsible.
Yeah, there's a lot of decisions that go into the visual design, and yeah, we're baking a lot of assumptions into the visual designs that we're making. But even in the same with machine learning and AI, and even with the data collection, which is actually why so I'm teaching a visualization class right now, and a big aspect of it is the ethics of data analysis and data visualization. So we have a whole session about question the data, question where it comes from, who collected it, for what purpose, what were they trying to do with it, and are you using it for a purpose that's appropriate for this visualization? Are you respecting the individuals who the data comes from? How do you responsibly visualize data? And then also, how can you mislead with visualization? We actually have a whole 2 lecture session where student teams so it's coming up soon, where they're trying to mislead the other team. So they have to kind of take a particular point using the same data. And it's interesting how vastly different stories you can tell with the same data.
So to practice by intentionally misleading teaches a lot about what's possible. Reminds me of debates where you take a side, even if you don't happen to believe that side, as a way of exercising the logic of it. We have
I believe visualization is actually a good tool here, because it's something that more people can have access to. So people can actually ask their own question and question the stories that other people are telling. Plus, a visualization often shows more than just the answer to one particular question. And so it makes it easier to confirm that the story that you're telling is actually true. But it still is important to be responsible with making visualizations.
We have a related question about that. It says, in these explorations, one can make wrong conclusions, then blame AI. Do these tools identify or measure the possible error or bias?
The tools that I've built so far, we have not addressed this. I know there's some work from other groups that have tried to do that. It is a hard problem because you still have to assume that the data is true.
So how could that work? The corollary question is, how could bias, errors, or wrong perceptions be mitigated or acknowledged even? I mean, that's a little bit outside what you've been talking about today, but it touches on the course issues that you were just mentioning.
That's a very, very big question. I'm going to answer a subset of that, which is, how could we, for instance, help people recognize that a visualization is not effective in misleading potentially? There's actually been work that builds on the tools that I talked about today, which creates so-called visualization linters that try to automatically recognize potentially misleading visualizations and warns designers that about potential problems. So, for instance, a very common problem is making a bar chart that doesn't start at 0, and that's misleading because we visually read the value as the length of a bar. So if the bar doesn't start at 0, then you can't actually read then you can't compare the values. So that's important to have.
I'm hearing the voice of Edward Tufte in the back of our heads here, talking about basics of data visualization and misleading data viz and so on. That's obviously another whole area. We've got a couple of other quick technical questions that might be fun to do quickly. Here's one. What are good visualization tools for natural language processing, text, image, audio, video data?
So those were a lot. For a lot of these data, there is not necessarily, or for any data, there's no correct visualization, right? There's no inherent visual representation necessarily. You always have to pick something. And a lot of the principles I've showed today can be applied to any of the data you just talked about. So by thinking about marks and visual encodings, you have to think about what do I want to show from the data, extract those features, and then map them to visual properties of one of the marks that exist, like bars, lines, areas, and so on. Or text, right? I can also encode the color of a text or the background, and making sure to apply the visualization design principles that exist.
So the tools that you've been talking about could be used for this other kind of data?
Absolutely, yeah. There's probably tools that are more suited specifically, for instance, for text visualization. But if you're extracting statistics from text, then those tools are a perfect fit. If you actually want to use Vega-Lite, I would recommend using the Altair library. Altair is also a star constellation, which is a Python wrapper around Vega-Lite, and it's quite popular for making charts.
Great. Another question about approachability. Is the UI friendly or easy to learn? And what's the trade-off with Tableau, aside from open source, your stuff being open source?
I guess that question in particular targets Voyager, which we've done studies with participants. We actually collaborated with Tableau on this tool. So we had some of the researchers from Tableau worked with us on it. Voyager it's a research prototype right now. We've not developed it to the point where it can work with large data sets. So Tableau works with massive data sets. Voyager certainly does not. Voyager's data import is probably not perfect. It is currently at the stage of a prototype. Vega-Lite is production ready and is being used. Voyager's is what I would say right now it's not. So you can try it, but use it at your own risk, I guess, right now. Falcon, similarly, it's a prototype that is, you have to specifically format your data in a way so that the tool can use it.
Right. So let me ask you one more broad question, and then we'll do a soft close at around 2 to be respectful for those who have to go. And then some of us can keep going. There are some other technical questions that might be good to answer. Zooming out a little bit, if you want to work in the area of data visualization, what do you need to master?
Okay, if you want to do everything perfectly, then ideally you would be a designer, computer graphics, you would know statistics, you would know data science, and all these things. That's if you want to master and be perfect in all this. If you want to get started, I think the important thing is to have a question. Have a question about data and be thoughtful about what tools might help you to answer that question. So having some basic understanding of statistics, of what do averages, medians, means, quantiles, min-max, what do those mean? Being able to apply some data transformations with SQL or Pandas or R, and then thinking about, and then knowing the basic principles of visual design. Some of it we've talked about today. There's a little bit more to learn about the different visual encoding channels. I briefly touched upon the fact that different channels have different effectiveness. There's either visualization classes that can teach that, or there's also some books that teach that very well.
Great. You made my day, Dominik, by saying that the skill of asking questions is foundational. That's really wonderful. Well, let's do a soft close, and then we can continue for those who have some questions unanswered. So thanks very much, Dominik. Absolutely fantastic. To the audience, thanks all for coming, and stay tuned for an announcement about an event in October for the week of the 25th. We're still setting the exact day and time. And the title of that will be Applying AI to Voice of the Customer, the Opportunities and Challenges. And that'll be hosted by Raylan Musaraka, one of our wonderful colleagues, who has considerable professional experience in retail. And she brings all of that to a powerful way of talking about these things with some guests. In the meantime, look at our website, cmu.edu/enable, E-N-A-I-B-L-E. You'll find information about what we do, why we do it, and prior events. And also, we'd like to hear from you in an interactive, collaborative way. What are you interested in? You can write to us at enable, again, E-N-A-I-B-L-E, at cmu.edu. And we encourage you also to consider becoming a sponsor, which is the deepest way to get involved and participate in the community and what we're doing, building this synthesis of technology and design innovation. And for more info, you can reach out to Chris Kissel at the Enable at CMU. So that's our soft close. Thanks to everyone. Some of us will hang on. Thanks, Dominik Moritz. Really appreciate it. What fun. We'll keep going a little more. Thanks to everybody else. Louis Kappa from Media Services, Laura Alford, Chris Kissel from School of Computer Science, and of course our sponsors at Enable, Progressive, and Zendesk. Thank you. But we're going to hang on. Those of you who need to go, carry on, and we'll keep going with some other tech questions here. Mm-hmm. So yeah, we'll keep going. How does Falcon achieve real-time zero latency interaction?
Great question. I didn't have time to go into the details today. At the high level, what it does is that it leverages an insight about human perception, which is that certain interactions need to be really fast, while it's okay for others to be slow. In particular, we found that, or others also found that changing which view you're interacting with is okay if that takes a while, but this brushing and seeing the response has to be instant. So what we did is we actually pre-compute all possible, for all possible interactions, what the histograms in the other charts look like. And we do that at the moment when you switch from interacting with one view to another. It's super subtle in the talk, but you can actually see there's actually there's some delay that's happening before the updates, the first updates come in after you start interacting with a different view. And that's like the couple seconds when the system does some pre-computations. And we can actually offload that computation to a server, in which case we can run over billions of data points. So I showed the flight dataset today. I've built a similar demo on a dataset from the Gaia Space Telescope, which is a space telescope that flies around the Earth and records basically every known star. It's like the biggest star survey. And it's like 2 billion something objects. And so that's a couple terabytes of data. And you can interact also instantly because we actually decouple the interactions from the raw data through aggregation and this pre-computation of the indexes. But the cool thing about these indexes is they're the same size regardless of the original data size because they're an aggregation. There's a lot more details in a paper. It's linked from the Falcon website. So if you go to github.com/vega/Falcon, there's a link paper that explains all the details. But if you want to use this in your own tool, get in touch, and I'm happy to. There's some more ideas we have about actually making it usable. Looking for support, for instance, right now, and actually making that more usable.
Right. So, do you have, speaking of other sources, do you have recommendations for books, articles, best practices in how to ask good questions for data exploration? How to become a good data visualization scientist, so to speak?
How to ask good questions. There's one resource, which is a book that my mentor, when I was at MSR, Microsoft Research, wrote. So his name was Daniel Fisher, and he wrote a book with Mariah Meyer, who's a professor in Utah. And the book is called Making Data Visual. And it's interestingly only a little bit about visualizations. A lot of the visualizations are made with Vega Lite, by the way, but it's only very little about visualization and a lot more about how do we even get to the point of asking the right question, asking a question that can be answered with data or visualization. So that is a good time point. This is a super thin book. So
those are great refs, and maybe we can collect those, Dominic, and put them in the follow-up email that we'll send to everybody who is registered here. That'd be great to collect some of those. Obviously, if you have a great data visualization environment but don't know how to ask questions, you're stuck. But if you have the capacity for asking great questions, then the tools you use, you see the point I'm trying to make. I hope that's not too much of a stretch. So bouncing around a little bit, any pros and cons to Vega Lite versus Tableau versus Looker versus others, just quickly?
Yeah. Well, Tableau is a company. It's a UI tool. It scales fairly well. Vega Lite, actually, people at Tableau use Vega Lite for like prototyping and building tools on the web. Vega Lite is a web. It's a library for the web and open source, freely available, so you can modify it and change it. We're still actively developing it, though. So there's still new features coming out every now and then. Looker, I think, was bought, so I don't know what the future of it looks like.
Okay. Another tech question before we zoom out again. Mm-hmm. Do the tools support auto data transformation, such as log or data engineering? That's the question.
Yeah. So Vega Lite has built in you can transform data, like you can do binning and aggregations, filtering, pivoting. Yeah, it's built in.
Right.
There's some other tools that I haven't talked about today that are specifically built for data visualization, for data transformation. Maybe in a follow-up sometime later, I can talk about those.
So two more, and now we're zooming out a little bit and changing focus in a sense. So I'm going to read this verbatim. I think it's quite good. What's your take between visualizing data, seeing, making conclusions, which parenthetically is called assumptions here, which is interesting, versus forecasting, making predictions? So that's the first question. And then that's in the context of a second question, which is how does AI and ML change that?
Yeah. Visualizing data is, I think, it's a lot of the mechanics of how do we take some data and make it into a form that we can then consume it. So that's the visualizing part. And we should build it in a way that we can leverage our perception system. Making conclusions is something that a human does. The person does that. And the person is ultimately the one who's deciding on the value of any kind of result of the analysis. Similarly to statistics, right? You have to be able to interpret the results and draw conclusions from them. To me, assumptions that kind of come before conclusions. Assumptions is something I have about data, and often I have a lot of unwritten assumptions that I might want to test before I build on those assumptions in order to get to other conclusions. And then forecasting is when you know what your data is about and you try to predict the future. You try to predict what is some value going to do based on another value. And you're doing that based on the past and hoping that the past is somewhat indicative of the future. And I think it's super critical to, well, first make sure that the data is actually representative of something that's going to happen in the future, right? If we're making let's assume we're at the beginning of the COVID pandemic and we're looking at past data and trying to use it to make predictions, and then all of a sudden a pandemic hits and some of our assumptions were incorrect. Some of the distributions are not correct. Then our models are going to do incorrect things. Or what's happening in Britain right now, where people are panic buying fuel, and there's 30-minute lines in front of the gas stations, and half of the gas stations don't have gas anymore. It's because nobody knew that the news are going to say that, well, we're running out of people who can deliver the fuel, and then there's huge lines, and it's kind of a self-fulfilling circle of having more and more usage. So the prediction models didn't work, right? Because they were based on assumptions that didn't hold anymore in the future. And so visualization can hopefully help us to make sure that we're building robust assumptions. How might this evolve with new developments of AI/ML? I think there's another quote in the Tukey paper that I started my talk out with. It's a fantastic paper, by the way, and it's about the future of data analysis viewed from the 1960s, and a lot of the assumptions or a lot of the state of analysis and AI and computers and so on is still true from exactly how he described it or how they described it in 1960. It's like almost the same, you could say. It's happening today. And so one thing they say then is that, quoting roughly, is today's task is not to invent wholly new techniques, in particular visualization, but rather to recognize and reorganize the vital aspects of existing visualizations and organize and reorganize them in new ways to fit new opportunities. And so I think there's a lot of developments, but a lot of the basic statistics, visualization, tree models or basic logistic models, they might still work pretty well. And so it's important to take the tools that we have already and make sure that we're using them effectively and correctly. And that might be the first step before even going into using the latest and greatest deep learning model. Sometimes you have to, because the existing tools are not enough, but often it's reorganizing what we have in ways that can adapt to new needs.
So Dominik, here's our last question about ethics. You've touched on this, obviously it's a concern of yours in terms of the data and the bias and so on. The specific question is, are there aspects of ethics embedded in the tools that you've shown? And if so, how can that work?
The answer is unfortunately no. There is nothing really built in, and it's hard.
Can it be done?
Ethics is it's a people problem, right? We have to educate, and I think our tools are enablers. Machines are enablers. They're letting us do things letting us do things better that we can also do otherwise. There's actually a whole paper on this, the theory of what they call, forgot the name exactly, but it's on saying that computers are not really, or any kind of technology is not really changing the way we do things. It's just letting us do things that we would already do, just faster. Like we could already talk to each other, but then telephones enabled us to talk over longer distances, or we could already give talks, and with Zoom we can do this over longer distances, and even during a pandemic. It's an enabler. Enable, just like I set this up. And so yeah, computers are enablers. And so I don't know whether they can really build ethics into them, or whether it's really people have to responsibly use the tools, and we have to make sure to educate people and give, I think, more people access to the tools. So, because I think equal access enables people to also be informed citizens who can question assumptions, question conclusions from others.
I value the question. I appreciate the question is asked, but I agree with you, Dominik, that I don't see how a machine will understand what ethics and what bias really means, because these are human values and aspects of being human in a social system, which computers do not and cannot, I will say strongly, ever really understand. And so it's our responsibility as technologists and users, both makers and users, let's say, to be vigilant about that and to teach it in classes, as you do and as I do in other situations of interaction design and so on. But this comes back to the fundamental point, and maybe we can close here. And Dominik, you may have some closing comments too. What I hear over and over again is what I would call the democratization of data visualization.
Mhm.
This seems to be a theme. Correct me or refine me if I'm not getting the nuance right. You want everyone to be able to ask questions of the data and thereby learn for themselves and be responsible themselves for how they think about the world they live in.
Yep.
Any comments on that and any closing comments from you?
Yeah, so this everyone here is, it's actually supposed to be really everyone. And I think that's something important, especially in data visualization, that we're making tools that everyone can use. So for instance, we recently started looking more into accessibility of data visualization. How do we make visualizations for people who have cognitive disabilities, who are blind? How can they understand data that is visually represented, maybe in a slightly different form? How do we design visualizations in ways that they're accessible to everyone? That's a big aspect. And so that might be actually how some of these tools can encode our values, right? We could make a visualization tool that only works for people who have big computers and lots of money and can buy the tools, or we can build tools that are open source, where there's a community of people making decisions, where research influences how we use the colors, where there's alternative representations of the data that work for people who use screen readers, where the data visualizations can be made in a way that they're accessible by a web browser, even a web browser that's working on a mobile phone or a not so powerful computer with a low bandwidth connection. And designing in a way that we're not limiting the access is, I think, a really important aspect. And we as tool builders can do that. I think the tools, you're right, tools are not going to be ethical or making ethical decisions. People do that. And it's important in both designing tools and building tools and in using them, and then using them to communicate any kind of insight you're making, be it visual or in any other way. So,
wonderful. Thank you so much, Dominik. I think that's a perfect note to end on. My thanks to you. My thanks to everyone who joined and stayed, and also to the support staff as always. Thank you very much, everyone. Hope to see you next time.